Hi everybody. Today we're going to talk about the interval and radius of convergence of this series right here, okay? Several things we should talk about beforehand. So we know that the absolute value of x minus 3 is going to be part of the answer, okay? What else are we expecting? We're expecting, since we see an exponential component here, we're expecting to see 1/2 pop out of this. If the 2 to the n had been in the numerator, it would be 2. Okay? So we're expecting to see these things come out of the ratio test. That's the first part of what we're supposed to do here. Then after we do that, we need to look at the endpoints, and we'll get to that in a second. All right, so the ratio test says that we should look at the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. All right, so that's the limit as n goes to infinity. And here's what I'm going to suggest. Do not try to simplify anything on the first step. That should be for a second step. So we're going to write n plus 1, x minus 3 to the n plus 1 over 2 to the n plus 1. All right, and then a sub n in the bottom, so that would be n x minus 3 to the n over 2 to the n. Once again, it's important that you write this step down, because if you try to simplify and you just do the slightest little bitty thing wrong, they're going to take off with that on the AP exam. They're not going to give you credit for actually knowing to do this. But if you write this step here, they have to give you the point for using the ratio test. So, all right, limit as n goes to infinity. So let's see. So we know we're supposed to cancel some things, right? So we're going to rewrite these. Everything that's written to the n plus 1, we're going to write it as that thing to the n times that thing to the 1. Okay? So this is going to be n plus 1, and that's x minus 3 to the n times x minus 3 and over 2 to the n times 2. Okay, we're going to take this one and flip it, and we don't need to change any of it. So this is going to be 2 to the n and n x minus 3 to the n. Okay, the reason I like to do it this way is now we can have our cancel party. And so the 2 to the n's are going to cancel, the x minus 3's are going to the n's are going to cancel, and we need to sort of, at this point, take a look at what's left over. We have an x minus 3 and we have a 2. There's no n's in either one of those, so we're going to pull them out front. Now, absolute value-wise, the only thing that can change sign is x minus 3. So I'm going to take the absolute value of that, and I'm going to stick that out front of the limit. And then we'll see what's left over is going to be the n plus 1 and the n that we can actually take a limit for. Okay, so, all right, so, oh, whoops. Sorry. So, like we said, x minus 3, and then over 2, and then the limit as n goes to infinity, okay, and we have n plus 1 over n. All right, the degrees there are the same, so we look at the coefficients of the leading powers, and that's going to be 1 over 1, so limit of this part is just going to be 1. So that gives me x minus 3 absolute value over 2. All right, so let's see. We've just done the ratio test, and we've gotten most of the information we need out of the ratio test. The ratio test says that the series converges when the limit part is less than 1. Well, that's the answer to the limit part, so we set it less than 1. So at this point, we multiply both sides by 2. And we get that absolute value of x minus 3 is less than 2. So this is the end of the ratio test, more or less, and it tells us an interval to look at. So this interval, if you think about it on the number line, is saying that the distance from 3 is less than 2. So if 3 is here, we can go 2 that way and 2 this way. So 2 this way is going to be 1, and 2 that way is going to be 5. Okay, so the interval we know about is this interval. We don't know about the endpoints. So at this point, we have to test those. All right, so let me create some room here. Now, when you're coming up with a test to use here, a couple things should happen, okay? When I substitute these numbers in, the exponential parts are supposed to cancel. So if we let x equal 5, we're going to have n, 5 minus 3 is 2 to the n over 2 to the n. And I think we can sort of see those 2 to the n's are supposed to cancel. That always should happen. If it doesn't, you've done something wrong, okay? So this is going to be a pretty divergent series. And let's see, what reason could we say it's divergent? Well, the limit as n goes to infinity of n is infinity. So we could say that it's divergent by the nth term test, if nothing else. Okay, when we plug in 1, so typically what happens here with these series is when you plug in the second point, or when you plug in one of the points, you get an alternating series. When you plug in the other one, it's not. In this case, we are going to have an alternating series here, so we're going to have 1 minus 3, which is negative 2 to the n. This is going to diverge too, same reason, more or less. So all right, so it's probably easier if you were trying to cancel that you write out both of the parts. So the alternating part and the power part, so that you can cancel those. And once again, we can actually even use the same reasoning. This is going to be divergent at 1 because of that, okay? Now look, let me back up here and say, if you're getting to this point and you're testing the endpoints and you have the urge to do the ratio test, something is wrong, okay? The ratio test is giving you everything it can give you here. And usually what that means is you somehow have the wrong radius. It's a real common thing for people to see over 2 and say the radius is 1/2. Very commonly people do that mistake, and that would come out when you look here, okay? So you would be able to tell that, oh, all the exponential parts didn't cancel. So just be aware of that. That's something that should happen. All right, so in this case, we're done. The radius was back over here, and the interval is the open interval from 1 to 5. Great. Hope you enjoyed this. Toodles.